Today we're going to be presenting a webinar called From Docs to Tables on LLM-powered information extraction in Predibase. So in this webinar, we're going to go through the following outline. First, we're going to talk a little bit about LLMs today. So if we should really be chatting with our data lakes, a new workflow. So we're going to propose a new workflow that centers around information extraction. And then finally, we're going to see a demo from my colleague, Wael. So to kick us off, let's chat about the reality of things, which is that you've probably used an LLM before, and that LLM was ChatGPT. So this past year, OpenAI's ChatGPT brought language models to the mainstream. Millions of people signed up, including my grandma, and were greeted with a minimalist chat interface that allowed them to ask a huge variety of questions, including knock-knock joke writing. But the key trouble with ChatGPT is that it's only accessible through an API call to OpenAI. Almost immediately after gaining popularity, people wanted to connect their private data to an LLM of their own in order to get it to answer questions and extract insights from their data lake and otherwise. This chat interface, as the primary interface to LLMs, has become dominant even in private offerings, but this leads us to ask the question, should we really be chatting with our data? Because chat interfaces, while fun, are fundamentally limited. The chat-style deployment for LLMs is exciting, but is somewhat limited in its ability to expand beyond toy use cases and into production. The first reason for this is because they're slow. And what we mean by that is low throughput. So chatbot deployments are built with interactivity in mind, which means that they're suboptimally configured for processing large quantities of data that you might expect in a production grade system. Also, LLMs are generally very imprecise. So off the shelf, they give pretty verbose responses to simple questions, and this makes them a pain to deploy as just another service if you plan to try and consume their responses in software ecosystems. And then finally, at the end of the day, chatbots are terrible data analysts. So if you try to connect your private data, the most popular implementation of chatbots today are unable to answer basic questions that might be expected of them from data analysts. And the reason for this is a fundamental limitation in the architecture of the most popular private Q&A systems. These architectures actually use what we are seeing to be called as vector DBs. And a vector DB, for those who aren't familiar, is a piece of architecture that retrieves relevant text from your data lake in order to support question answering. So what this means can be shown in the diagram here, where we have a user asking for the revenue of Business Corp in 2021 and with this question, that what they want to know comes from this set of financial documents, or 10Ks, that are indexed by the vector DB. What a vector DB allows you to do in tandem with a model that does embeddings is read this question and find a handful of text snippets, so usually between 1 or 5 or 10 snippets, that contain relevant information to this question. So in this case, the vector DB returns a page of Business Corp's 10K, a financial overview document from 2021, and this can be useful by itself. However, when paired with an LLM, this process can seem quite magical. So here, if we have a vector DB and an LLM deployment, we get what we see today as a very common Q&A system, where the page of text is given to the LLM first as context to the question, and then that page of text is then processed and sort of formatted as this natural language answer. So in this setting, this retrieval augmented LLM is able to take in, well, I guess the user passes the question about Business Corp in 2021 to the vector DB, which then finds the top most relevant document, passes that to the LLM, and then the LLM reads that and then outputs the answer, which here is 15 million. Now, the issue with this is that these retrieval augmented LLMs demo super well, and hundreds of millions of dollars have been raised off of the backs of these kinds of demos. However, these kinds of single source questions are hardly the only kind of question out there. And what we're starting to see is that these VectorDB plus LLM deployments simply cannot handle the complex aggregation style questions that are the bread and butter of data analytics. So, for example, if the user wanted to ask a question that pertained to the entire corpus of financial documents, such as which company had the highest revenue between 2010 and 2023, there is no handful of documents that the VectorDB can return to give the LLM enough information to answer this question correctly or even at all. So instead, the VectorDB will likely return a handful of documents deemed relevant because of the text in the question. In this case, the 10K of some fictional high rev company is returned due to the similarity of the text within. The LLM will read this 10K, compare it to the question, and in the best case scenario, it will respond with, "I'm sorry, I don't understand." And in the worst case scenario, it will hallucinate. So some of you may be wondering why such questions would pass through a VectorDB service in the first place. You probably are saying to yourself, why not just ask the LLM to read all of your documents directly? The reason why you can't do this today is because LLMs have a finite context length, which is the amount of text it can read before responding to a question. 10K filings are notoriously long, and if you have even a slightly non-trivial number of them, like 100, you're looking at about 4 million words or 5 million tokens. There's no LLM today that can take this as input, and the user is most likely to receive an error code for their troubles. Now, of course, this leads us to asking the question, is there a better way to surface insights from data using LLMs? And the answer, obviously, for this presentation is that there is. At Predibase, we propose that with our toolkit, one could build an LLM-powered information extraction system. An LLM-powered information extraction system would use LLMs to turn your unstructured data into tables for downstream analysis. So in this example, we've taken away the VectorDB and added in an LLM capable of doing batch processing as our sort of architecture for deployment. We then take each document and ask the LLM to answer a series of point questions about the documents. And each document question pair is then processed and populates a cell in a SQL table constructed for the entire corpus of documents. With such a table, we'll be able to do arbitrarily complex analysis. So returning to the question from the previous slide, which company had the highest revenue between 2010 and 2023, what we can do after we've created this table is ask a text to SQL LLM this same question, create a SQL query for the table that was just produced, and then finally take its output as the answer to our question. What this means is that analysis over the documents is efficient and straightforward. Now this question can now be answered using commodity pieces such as the SQL table, and is not necessarily contingent on the ability for us to either fetch some single source document or the ability to process every single document at the same time while trying to figure out the answer to this question. Okay, so that's a very, very high level overview on what information extraction could be, and is sort of this first foray into what LLMs could look like beyond chat. The information extraction workflow described enables a largely untapped use case for LLMs in production, and with this implementation, or at least with our implementation, you can achieve high throughput through LLMs that are specifically deployed in order to do batch processing. You can achieve structured outputs in our implementation through data schemas that enable output coercion and validation. And finally, probably the most important thing is if you think about using LLMs in this information extraction way, it enables LLM-powered analytics, which means that it becomes easy to extract structured data from unstructured documents, like it's just another table in your database. All of the components required to build for this sort of workflow are available in what we're building at Predibase, which is the developer platform for AI. So Predibase is a builders first platform where we give you the tools in order to manage your data, your LLM deployments, and also manage how these are tracked and versioned over time. So among the things that Predibase offers is the ability to connect your data via Snowflake or BigQuery or S3, the ability to execute ML operations from our SDK and UI, such as training, inference, and data processing through our YAML configs, which are processed by Ludwig, a popular open source ML engine that we maintain. You can also track changes over time through our GitHub-like version control system. And finally, you can deploy models for either batch or real-time inference through our Python SDK and UI. All right, and all of this, of course, is built on top of fully managed scalable ML infrastructure, which is built on popular open source libraries such as Ray and Horovod. For today's webinar, our next presenters, Jeff K and YL, will discuss how exactly the information extraction jobs that I was describing are defined in Predibase. And with that, I'll hand it over to Jeff.
All right, thank you, Jeff. Just going to, okay. Can we see the presentation?
Yes, we can.
Okay, thank you. Yeah, so today we're going to, thank you, Jeff. We're going to walk through how to do information extraction in Predibase using mining data from Form 10K as a motivating example. So for this, we want you to imagine that you're a portfolio manager with hundreds of 10K reports for potential investments. These reports are hundreds of pages long each. The information you're looking for is potentially in some combination of plain text and tables and figures. So it's not straightforward to extract, but you have analytical questions spanning all the documents to inform potential investments. And your vector DB is struggling to extract that insight, likely because of just how large the documents are, the varied nature of the data. What we are offering is a 3-step process to extract data from these documents and from more general unstructured documents. The first step here is to describe the data. So you're going to define an extraction schema to guide the LLM to data that you need. The second is to extract. So you use our SDK to send the schema and the documents to an LLM, and we'll get you back a table of data that you're looking for. And lastly, you want to analyze your data, where you can use your own data science workstream or upload back to Predibase to use our platform. So overview, the process kind of looks like this. As I described, you define the schema, you have some set of documents, and you use our SDK to get to the LLM. And in this case, we're going to look at 4 different pieces of data that you might want to get out. The stock symbol for a corporation, the stock exchange that they're registered under, effective tax rate from 2022, and the number of stock classes offered by the company. And what we'll see is that each 10K, you're going to get 1 row in a table out, and that will have all the information that we've been able to find based on the questions you want to ask about your data. To start, you're going to describe your data. We we allow you to define a data extraction schema where you can select a model that you want to use, and then define some parameters about the features that you want back, including the name of the feature, a data type, the prompt you want to ask to get to that data, and various constraints on a per data type basis. As of now, we have largely 4 broad data types that you can work with. The first is categorical, where you can ask a question and specify specific answers that you're looking for. Second would be a more general text feature, where you have a question like what's the stock symbol, and you know a pattern that you can validate against, a regex pattern that you can validate against, and we will screen the responses based on that. You can also describe, or you can also set up numeric data where you look for integers or real numbers, and you can set bounds on those based on your domain knowledge about what you're looking for. So for example, how many classes of stock does the company have? You're not likely going to want a negative number. So you can just straight up specify that the answer must be positive. So each of these has a question associated with them that we're going to use to extract the data, and then the remaining parts of the schema are used for validation. So once you have your schema defined, the next step is to load it and the documents into our SDK. But as I mentioned, the documents themselves, the 10Ks, are potentially hundreds of pages long, which is infeasible to run through a standard chat interface or even many basic interfaces to LLMs through API calls. So we are going to do a few things behind the scenes to make this possible. Once you have loaded your data in, we're going to split the documents into chunks based on a number of tokens per chunk. You can define some amount of overlap between chunks. For each chunk, we're going to run the prompt for that column. So to extract the stock symbol, say, each chunk is going to be used as context to answer the question, what is the stock symbol of the company? And as with any LLM prompt response session, you're going to get back 1 response per chunk. Apologies for any sirens on my end. You're going to get back 1 response per chunk, and these may or may not contain the answers to the questions that you are looking for. You might have hallucinations in some chunks. The answer may not be present in some chunks. And all of this is going to be collected into 1 aggregate response. And we're going to do the same for each of the other features. So we're going to ask the stock exchange prompt for each chunk. We're going to do the same for the tax rate and for the number of stock classes offered. And we're going to end up with this collection of responses. Now, when you're asking these questions of the documents, you probably just want a single response. You don't want to have to filter through all of the per chunk responses, filter through undefined answers or hallucinations. So the second step is to run a synthesis on all of the responses. What we do here is we take all of the answers per chunk and insert them as context into a synthesis prompt saying, given the question, what is the company's stock symbol, and all of these answers that we have, give me a single answer to the question. And the output of this is a per column textual response. This is still not the structured data that you're looking for. So the final step is that we take the synthesized responses and we run them, we validate them back through the schema. to cast them into the correct data types, to isolate and extract individual answers, to potentially do some modifications like taking textual numbers and converting them into digits. And what this gives you is a table with one column per document, gives you one answer to each question that you asked per document in the data types you're looking for. And this is ready to go for export to use in your own data science pipelines. Or you can also use Predibase to analyze your data by directly connecting table to Predibase and then training a model, querying using that trained model to get insights and predictions, and deploying the model you just trained on your extracted data on a dedicated serving engine for production inference via a hosted endpoint. So this is generally what information extraction looks like in Predibase. And now that we have an overview of this, I'm going to hand it off to Wael for a demo of our process. Wael.
Thank you so much, Jeffrey. Let me start by sharing my screen. All right. Awesome. Yeah. So our use case is to take a number of 10K filings and to turn them into tables. And for people who don't know what 10K filings are, these are financial documents that are submitted yearly by publicly traded companies to inform shareholders and the public in general about the financial health, as well as the general health in terms of the for the business. If we have a number of these documents and we would like to ask trend type questions that we can find in each of these documents, such as which companies met their earnings per share objective in 2021 or over a number of years, or which companies laid off employees. This is very difficult to do with a vector DB solution. And we tried that. So this is the query editor in Predibase. This is where you can query your private large language models on your private data in our platform. So in this case, the large language model that we're choosing is the recently released Llama 2, 13 billion version. The data set is a 10K filings data set that we took from PDFs transformed into text. And we indexed this data set using this large language model, and we asked this question. So the question is how many employees were laid off, and the response is it's not clear from the given context how many employees were laid off. The text mentions that the company had 190,000 employees in December, but does not specify whether any of these employees were laid off. So what probably happened here is we are able to retrieve a number of relevant chunks, but we're not able to create a response that captures the answer over multiple documents. So that's why we're showing you this demo, so you can see the difference between a vector DB approach and an information extraction from unstructured documents to structured tables approach. We start by importing this unstructured collection in Predibase, and we load our documents from this S3 path. In Predibase, you can connect your data from multiple sources. These are the sources we support. They range from blob storage such as Amazon S3, Google Cloud Storage, Snowflake, etc. But for this demo, we're going to be using S3. So what I have in this S3 path is a number of PDF documents. I have about 10 of them. Each of them for one 10K. And this is what a 10K looks like. It's about 78 pages for this 10K. It discusses some business details about the risks associated with the business, for example, the key officials of the company, but it also has tables where that store a lot of numbers that may be of interest to people who are working with these documents. So once these documents are loaded, they're taken from their PDF format to the text format, and I would like to show you what one of these documents looks like under the hood. This is the 10K filing that I just showed you under the PDF format. We're just going to transform it into the text format. And as you can see, it's just plain text that we're going to be querying. And we have multiple of these. So the question is, how do we move from unstructured text that looks like this to a structured table? So this is the describe your data step. The way we do it is by defining this config, which represents the target schema of this table. And what we do here is we define columns, we give them names, and for each column, since we're working with LLMs, we're going to be defining prompts. And our prompts are simple, very precise questions about what we would like to extract. So an example is, what's the filing fiscal year of the form, the name of the company, CEO, whether the company laid off employees or not, etc. And we have these validators for each type that we would like to extract. We know that the year shouldn't, since we uploaded documents between this time range, the year, for example, is not going to be out of these bounds. So we have this validation step to make sure that we add these guardrails around what the output is, since the LLM outputs are known to be non-deterministic sometimes. So once we define this config, we will move to the extract your data step. So this is where we move from a text to its corresponding chunks. For each of these chunks, we ask our question, the questions that we discussed in the config. And once we get answers for each of these chunks, we will generate the answer, the final answer for that document. So this process takes some time, depending on the number of documents you're working with and how long these documents are. It could take from minutes to hours. These are batch jobs that you could submit. Sometimes, if they're super quick, they will finish in minutes, but sometimes it will take overnight. But you can also specify a number of documents. So if you want to iterate on the prompts, and as we know, people like working with LLMs, your first prompt is probably not your last. So you would like to get to a reasonable prompt that can extract some data before you settle on a final prompt and submit the final job that could take hours. So all of these jobs already ran, and we have cached the answers so that we can show them super quickly for the purposes of the demo. All of these jobs run on Predibase infrastructure. The model that we're using is the Llama 2 13 billion. This is a privately deployed model on this privately deployed data. So once we're happy with the prompts, we can run this on the full data set. And what we're going to get is something that looks like this. So we're going to get a number of documents as rows, and as columns, we're going to be getting the columns. We're going to be getting the questions or prompts or columns that we defined as part of our config. So an example is, what's the filing year of the form? As you can see, we're able to extract these numbers, the name of the company, as well as the CEOs. So for example, the CEO of Google, the revenues, and whether the company laid employees off recently or not. So we get to this table format, and this is already useful, right? Because we were able to move from data that looks like this, that is very difficult to parse, and very difficult to extract information out of, to something that looks like this. So this is what these two data sets look like in Predibase, right? So if we're able to see this data as a table, we're able to see some statistics on when these documents were submitted to the SEC, for example, if there are any statistics on revenues, etc. Right? So this table can already be used for analytics in some other using some other software or some tools such as Tableau, or even in your own notebook using Matplotlib, for example. But what if we want to ask a natural language question on our data, right? So for example, we want to see how many companies laid off employees, and we want to apply this query on this table. So if we look at this table, it's a pretty small table, and we can really see how many companies laid off employees, and there are exactly 4. But say you ran this really large job on thousands of documents, and you would like to ask questions on any combination of these columns with specific conditions and filters, right? So that's where some of the challenge could be, especially for people who do not speak SQL, right? So what we're going to do here is generate the SQL query from this natural language query and synthesize an answer out of this table. And what we get is this answer. We get the count, which is 4. We also support getting attributions. So if all these answers that you see here are generated by LLMs, and even though there is a step that happens after the generation to validate these answers and to make sure the quality that you get is good, it's also very important to provide another layer of transparency. So if we would like to, for example, for Apple, get the sources of this answer, for example, for this Apple Inc. answer, where did this answer come from, right? What parts of the documents did this come from? This is where we can run attributions. And what attributions will get us is the specific chunks where we got this data from, right? So remember, our PDFs are transformed into text, transformed into chunks of text that are passed on to LLMs to generate an answer. And this is what our chunks look like. So yeah, this is, for example, one of the chunks that was used to generate this answer. So perhaps Apple incorporated this somewhere in these chunks, and yeah, it is in this second chunk, right? So the summary is that we were able to not answer these aggregate style questions across multiple documents using a vector DB / index approach to being able to take these documents, run a batch job on our private data, on open source, powerful LLMs that are hosted in the platform, and extract this information into tables that we can use in downstream tasks. Chat is one of many interfaces through which we can interact with LLMs, but LLMs are really not just chatbots. They're powerful tools that can also enable us to extract information. Chat interfaces, they're very flexible, but they fall short in terms of structure, predictability, and repeatability in output. And we wanted to offer another interface and offer the infrastructure behind this interface to turn unstructured data into structured data so that these tables can be used for downstream analytics tasks and machine learning tasks.